Mastering the Docker command. Welcome to the fourth section of this video course. So far we've got to the point where we can pull down an image from the Docker Hub community and return a new one to it. In this section, we're going to master the Docker command in more depth. We're going to understand the differences between images and tags, understand the differences between repositories and registries, and learn how to run and manipulate containers. By the end of this section, we'll have mastered the various commands that allow us to manage Docker on our machine, managing images. In the previous videos, we've used Docker images and containers and pulled and pushed images to and from the Docker Hub. In this video, we're going to take a closer look at how Docker works on our machine and some of the commands at our disposal to manage it. We're going to use examples to understand images, repositories, and registries. Use the Docker tag command to understand tagging, and use the Docker history and events command to understand image layering. By the end of this section, we'll have gained a greater mastery and experience of the Docker command set, which will give us greater confidence as we go on. Earlier we tagged an image with the Docker tag. It's worth exploring a little more in detail. As we already know, an image is a particular and unique template for Docker containers that we've pushed to the Docker Hub. The Docker Hub is an instance of what's known as a Docker registry. Registries can be open to the public, like Docker Hub, or private to your network. These registries contain repositories. These repositories consist of the images we've seen, like your username / your image name, or just Ubuntu. If there's no username followed by a /, then the repository defaults to being centrally managed at the Docker Hub by Docker themselves. You cannot push images to these repositories, or any repository apart from ones in your own username space. Within these repositories, you can have different images tagged. These are placed at the end of the repository, separated by a colon. For example, type docker pull ubuntu trusty, which will pull the trusty or 14.04 version of Ubuntu. If we then pull the same repository with a tag of 14.04, docker pull ubuntu 14.04, and then type docker images, we can see that they have the same image ID, i.e. they are the same image with a different tag. If we tag it again with myref, type docker tag ubuntu trusty ubuntu myref, and then docker images, we can see that it's still the same image, just with another tag. If we type docker pull ubuntu 12.04 and then run docker images, we can see that that version has a different image ID. By default, Docker gives you a tag of latest on your images. You can tag any committed version of a container. Next, we're going to look at image layering, which is a related subject. When we uploaded our own 2048 image, we saw that only the files that had changed from the original image were uploaded. Docker is smart enough only to copy files to your new image when you write to them. These changes are kept in what's called file system layers. By typing docker history and the image name, you can see the history of images and their layering. As you can see, each layer has a separate image ID, a date of creation, the command used to create it, and a size delta from the previous layer below. This layering allows an image's content to be shared across multiple containers. If the files are not changed, then effectively no extra disk space is used. It's similar to the way shared libraries are used by multiple processes on the same machine, with no more memory being required. You can think of this as shared libraries for Docker environments. This is one reason that many containers can be run simultaneously on one machine. We can see a history of activity on our Docker daemon by running the docker events command. Type docker events since equals 0 to see the history of containers on your Docker daemon. It tells you when containers were created and started, died and destroyed. In this video we've gained a greater understanding of Docker tagging, grasped Docker image layering using the Docker history command, and queried our system for Docker events on our Docker daemon. Now we've understood more fully Docker images, we are ready to look at managing containers on our machine using commands we've not seen before.